Hello and welcome back to another episode of Math with Zone. Today, we're going to be talking about how you can prove that triangles are similar. And there are only three ways to do it. You can have angle-angle similarity, which is really angle-angle-angle similarity. I just want to point that out. Side-side-side, or side-angle-side. And this is different than congruent triangles. So that's why they don't have as many, and they have slightly different. Angle-angle is not a congruent triangle way to prove that. So what you're going to do is just see if these triangles have that. The angle-angle is by far the easiest one. If you have two angles that are congruent on both triangles, they are similar. So it happened on this guy right here for that first example. It would also happen on this second example because these vertical angles here would also be congruent, and that would be angle-angle similarity between both triangles. Side-side-side similarity is, believe it or not, the hardest one because you have to prove that all three sides have the same scale factor or the same ratio. And the way to do that is by dividing in your calculator or by using fractions and simplifying, but calculator's a lot faster, the scales. So we're going to divide 3 by 6 in our calculator, and that needs to be equal to when we divide 4 by 8, and it would have to be equal to what we get when we divide 5 by 10. Now, I know I said it's easier if you use a calculator. In most cases it is, but in this case, it's pretty easy to see that this is 1/2, 1/2, 1/2. They all turn into 1/2, which is why it is a similar triangle, because they all have that same ratio. Now on the next one, this is a little bit harder to tell, and that would be where you would want to use your calculator to confirm that it is in fact a similar triangle. So if we would have 24 over 30, if I divided 24 by 30 in my calculator, 24 divided by 30 is 0.8. So I would need to make sure that all of the other things when I divide them are 0.8. So when I divide 28 by 35, that had better be 0.8 as well. And when I divide it, lo and behold, it's 0.8. And then when I divide 25, the last one, by 32, it had also better equal 0.8. And if it doesn't, then they are not considered similar triangles. This time it does. All of them are 0.8, and it's a similar triangle. The last one is side-angle side. So you have to have the angle in the middle for side-angle side, and you need to make sure that the other two sides that are in between it have that same thing that we just did, where we got 0.8, 0.8, or 1/2, 1/2. They all have to divide to equal the same thing. So we're going to take the 6 and divide by 8. I like doing the smaller one over the bigger one. And that had better be equal to 15 over 20. Now there's another way to do it as well, but it doesn't really work out as well for side, side, side. But for side, angle, side, you could just cross multiply here and get 120 equals 120. If that happens, then you would have got the same thing from 6 divided by 8 compared to 15 divided by 20. In both cases, they both equal 0.75 if you divide them. So you can get it both ways, but it's just another way to prove that they're similar is by getting things that are the same. This last one, you need to be careful because the small triangle is here. So that would be a 12, and the bigger triangle would be 21. So 12 over 21 had better be equal to 15 over 25. So we got to divide those both. So 12 divided by 21 is an ugly number. It's like 0.57. And if we do 15 divided by 25, we should get the same number. But we didn't. So my question is, what would that mean if I didn't get the same number? It's 0.6. Now those are close, but they're not identical, are they? And if that's the case, these are not similar because those did not divide and equal the same thing. So they are not similar. The first one ever that we've had on this whole paper that's not similar. Now, The one thing I do want to point out is both this small triangle and this bigger triangle shared that middle angle. So that when you have these where it's like the small one embedded in the bigger triangle, that is going to be more likely a side angle side similarity than anything else. So we're going to figure out if these triangles are similar or not by either confirming that it is angle angle, side side side, or side angle side similarity. Those are the only three options. If at any point you get something that gives you something other than that, maybe you get angle side angle, well wait a minute, that has two angles, that would actually be okay. But if you get something like angle side side, just like before, it would not prove similarity. Okay? So this first one, we have side, angle, side. We just have to confirm that the sides, in fact, are similar. Now you can divide them to do that. And you could also look at them in some instances. What does 3 have to multiply to get to 9? Well, that would be 3. What does 5 have to multiply to get to 15? That would be 3. They both have the same scale factor. Therefore, it would confirm it as well. And you could do 15 divided by 5 and 9 divided by the 3 and get the same thing. Number 2, we may not be as lucky because the numbers don't look like they can multiply that easily. But it will be side, side, side if and only if, when we divide in our calculator, they're all equal. And you need to be very careful of what side you put over what. 16 is the smallest side. I need to put it over 22 because that's the smallest side. 16 over 22. What does that get when we divide? 16 divided by 22 is 0.72. Then what do we get when we divide, let's say 20 by 28, because that's the sides, that's the medium side. 20 divided by 28 is 0.71. It is not similar, which is sad because those are really close. So not similar. It needed all three sides to have that same number. And if you simplified this fraction, if you divide both of these by 2, you get 8 over 11. But if you divide both of these by 2, you get 10 over 14, which is 5 over 7. They're just not the same fraction when you simplify them. And simplifying the fraction is the same thing as dividing in a way. Number 3. It looks like it might be angle-angle. It feels like it might be angle-angle. But we need to confirm that it is angle-angle. Right now, the only thing I know is that this part of that angle is 42 degrees. Well, they do have two angles, but they have to be the same angle. And 42 and 42 are correct. That's one angle. But 85 and 53 aren't. But wait. What would maybe be this angle? Is that 85? We could figure that out by subtracting these two angles from 180 to get the third one. So whatever 180 minus 42 and 53 is, if that's 85, we're in business. 180 minus 53 minus 42 is 85. So there we have 42, 85, which makes it angle, angle, similarity. There we go. And, by the way, this angle right here would be 53. That's why I said at the beginning of the video that it's technically angle, angle, angle. Whenever you have two angles, the third angle is going to be the same. This one right here, you could prove that they are similar via side, 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 or side, angle, side. Now, side, angle, side's quicker because you only got to confirm two sides. That angle shared in the middle would prove that the two triangles are similar. All right. If 15 over 20, I got 20 from adding 5 and 15 together to get all the way from R to P. That has to be the same as when we divide 18 by 22. Or we could have picked 12 over 16. So let's see what this is without a calculator. Whoa, wait a minute. 6 and 18, they do not add to 22. 6 and 18 add to 24. So doing it without a calculator, sometimes it's actually quicker, especially if you don't have one. If you divide both of these numbers by 5, you get 3 over 4. If we divide both of these numbers, the 18 and the 24, by 6, you get 3 over 4. they are the same thing. We do have that angle in between these two sides that I just picked. So this would be side angle side similarity. Now the next thing I want to do is, for this particular problem, it's kind of hard to see what the two triangles are. I'm going to write them out. This first triangle, the bigger one, I'm going to call QRP. So that triangle QRP is similar to triangle, the smaller one, XYP. Triangle XYP. When you have a common letter, odds are you're going to have a common angle as well. All right, so maybe one or two quick ones after this, and then we'll be done for the day. 5 is a little weird because they got these parallel lines here. And anytime you have parallel lines, there's going to be some equal angles. And if I focus on these two parallel lines here and here, I would know that those two angles that I'm marking right now are congruent because they're corresponding. And corresponding angles are congruent. But if I focused on two other angles, or excuse me, two other parallel lines here and here, I would get the other corresponding angles. And that means that I have not one, but two angles, and that is enough to prove that the triangles are congruent via angle-angle similarity. Last one, let's do it real quick. Shared angle in the middle. We just have to make sure that these triangles are similar from doing 35, not over 30, but over the whole thing, which is 65 when you add 35 and 30 together. And that has to be equal to 24 when we divide by 44 from adding the 24 and the 20 together. All right, let's just divide in a calculator. Let's see what they both equal. So I'm going to do them off to each side. 35 divided by 65. 35 divided by 65 is 0.53. So let's remember that. 24 divided by 44 is 0.545. They're close, but those two numbers are not equal to each other. 0.53 does not equal 0.545, which means that they are not similar. And I can't say side angle side anymore, which makes me sad because it would have been side and then the angle in the middle and the side, but the numbers aren't the same, so it's just not similar. All right, that's going to do it for this episode. Until next time, I will see everybody later. Bye.